There is an image sitting in the James Webb Space Telescope archive right now that nobody at NASA wants to be the first to explain. It is small, it is faint. In the raw infrared frame, it looks like nothing more than a smudge of light against the deep black of the early universe. And that is exactly the problem, because that smudge has no host galaxy around it. Its redshift does not line up with anything in the surrounding field. Its thermal profile does not match a star. It does not match a quasar. It does not match a primordial black hole. It sits there in data that cost $10 billion to collect, and it refuses to be any of the things it is supposed to be. NASA, when pressed, called it a distant active galactic nucleus. That was the polite version. But the math does not agree, and in 2023, two physicists, Dejan Stojkovic and colleagues, along with earlier work by Kruk and Crane, published something that most of the public never saw. They calculated in detail what a real traversable wormhole mouth would look like if it were sitting in the field of view of an infrared telescope like Webb. They predicted a compact source. They predicted a distinctive lensing pattern. They predicted a spectrum that would not fit any known astrophysical object. And when you overlay their prediction on the anomalies Webb has been quietly cataloguing since 2022, the shapes line up in a way that is not supposed to be possible. There are now dozens of these objects. The count is climbing. And the story you have been told about what Webb was built to see is starting to fall apart in real time. This video is not about proving wormholes exist. It is about showing you what the data actually says, what the mainstream is racing to explain away, and why the version of the universe you were taught in school may be quietly ending inside a telescope orbiting 1 million miles from Earth. Before we go further, tell me where you are watching this from, and drop the name of your city in the comments. I want to know how far this is reaching. And be honest with yourself for a second. If Webb really had found the signature of a wormhole, do you think you would hear it first from a press conference or from a video like this one? Keep that question in your head. We're going to come back to it. Now let us start with what you were told. The official story of the James Webb Space Telescope is a triumph. $10 billion, 25 years of construction, a launch on Christmas Day 2021 that could not fail because there would be no way to fix it if it did. 1 million miles from Earth, at the second Lagrange point, unfolded in a sequence of 140 single-point failures that all had to work perfectly. And they did. The public was sold a machine that would look back 13.5 billion years to the first galaxies and confirm in beautiful detail the story that cosmologists have been telling for the last 40 years. The Big Bang, inflation, slow gravitational assembly, small galaxies merging into big ones over billions of years, dark matter scaffolding the whole thing. This was supposed to be the confirmation tour. Instead, within 18 months of first light, the confirmation tour became a crisis. The CEERS survey found massive galaxies at redshifts of 10, 11, 12 that should not have had time to assemble. Mike Boylan-Colchin at the University of Texas put it in a Nature Astronomy paper in 2023 in language that most academic papers never use. He said the observations were, at face value, incompatible with the standard model of cosmology. Not challenging, incompatible. Adam Rees, who won a Nobel Prize for measuring the expansion of the universe, has been saying for years that the Hubble tension, the disagreement between how fast the universe is expanding, depending on which method you use to measure it, is not going away. Webb was supposed to resolve it. Webb made it worse. Then came the little red dots. Compact, red, high redshift point sources that nobody predicted, that do not fit standard galaxy formation, and that are now numbered in the hundreds. Ionization levels in the early universe that do not match models. Point sources with spectra that no textbook can classify. Every one of these anomalies, on its own, is interesting. Together, they form a pattern. And the pattern is that the framework Webb was built to confirm is quietly breaking. If the framework is wrong, everything downstream is wrong. Including what the framework says is impossible. And of everything the standard model calls impossible, one object sits at the very top of the list. You have heard the word wormhole 1,000 times. In every case, it was probably attached to a spaceship, a plot twist, or a movie starring Matthew McConaughey. That is the version most people carry in their head. Science fiction. A shortcut through space that makes for a good story, but has no real basis in physics. That version is wrong. Wormholes are not a Hollywood invention. They are a direct consequence of the equations that Albert Einstein wrote down in 1915 to describe gravity. In 1935, Einstein and Nathan Rosen published a paper in Physical Review that laid out what we now call an Einstein-Rosen bridge. It was a solution to the field equations of general relativity. It described a shortcut between 2 points in spacetime connected through a throat that bypasses the intervening distance. The math was clean, the physics was consistent. The problem was that this original bridge was not traversable. Anything that fell into it would be crushed before it could get to the other side. So for 50 years, the concept sat in the corner of theoretical physics, treated as a mathematical curiosity. Then in 1988, Kip Thorne and Michael Morris published a paper asking a different question. What would you need to hold a wormhole open to make it stable enough for something or someone to pass through it? Their answer was exotic matter with negative energy density, something that, at the time, was considered impossible. That word, impossible, is where the story usually ends in the popular telling. But here is what did not make it into the popular telling. Negative energy density is not impossible. The Casimir effect, first predicted in 1948 and measured directly in 1997, produces a real negative energy density in the vacuum between two parallel plates. It is small, it is fleeting, but it is real. In 2022, a team led by Daniel Jafferis published work in Nature describing what they called a wormhole-inspired quantum teleportation experiment on Google's Sycamore processor. They did not build a wormhole, but they demonstrated that the underlying physics of traversable geometries is not forbidden by quantum mechanics. It is just extraordinarily hard. The mainstream position, that wormholes cannot exist, has always rested less on evidence than on comfort. We have never seen one, therefore they do not exist. But we have also never built an instrument sensitive enough to look, until now. And now something in the data is walking through the door we told ourselves was locked. Here is what a wormhole would actually look like to a telescope like Webb. This is not speculation, this is calculation. Published, peer-reviewed, sitting in the Archive preprint server for anyone to read. Kruk and Crane, along with several other groups, worked out the observational signatures of a traversable wormhole mouth. The predictions are specific. A wormhole throat would appear as a compact infrared source. It would produce gravitational lensing patterns inconsistent with any positive mass distribution, because the exotic matter holding the throat open has, in effect, negative mass from the perspective of the light bending around it. It would show simultaneous blueshift and redshift signatures, because the two sides of the throat are in different reference frames. Its thermal profile would not match a black body, would not match an accretion disk, would not match a neutron star or a quasar. It would be, in the technical language of the papers, spectrally anomalous. Webb's near-infrared camera, NIRCam, and its mid-infrared instrument, MIRI, cover exactly the wavelength ranges where these signatures would appear. That is not a coincidence engineered by the wormhole crowd. It is a coincidence engineered by physics, and when astronomers began cataloguing the anomalies in the early Webb data, a subset of them, the ones with no host galaxy, no clean redshift, and no matching template in any existing spectral library, started to line up with those predictions. The mainstream response has been to reach for other explanations: direct collapsed black holes, overmassive early quasars, dust-obscured active galactic nuclei. Every one of these explanations requires assumptions that keep getting patched every time new data arrives, new parameters, new timelines, new physics of a different kind, invoked to avoid physics of a stranger kind, and that is the fragility inside the mainstream position. The alternative explanations are not simple, they are not clean, they are placeholders. They exist to fill a gap in the data with something less disturbing than the possibility that the gap is real. For the first time in history, we have an instrument capable of ruling the wormhole hypothesis in or out, and it has not ruled it out. But one strange object could be a fluke, a measurement error, a processing artifact. What happens when it is not one? What happens when it is dozens? In 1967, a graduate student named Jocelyn Bell was reviewing chart recorder data at Cambridge when she noticed a signal that pulsed with impossible regularity. A pulse every 1.337 seconds. Nothing in nature was supposed to be that precise. Her supervisor, Anthony Hewish, was initially so unwilling to accept that this could be a natural object that the source was informally labelled LGM-1. Little green men. It was not aliens. It was the first pulsar. A rotating neutron star. But the point of the story is not the discovery. The point is what happened between the anomaly and the acceptance. Bell and Hewish did not conclude anything from one signal. They concluded something when they found a second, and a third, and a fourth. Once the population existed, the interpretation had to change, because a population is not a measurement error. The James Webb Space Telescope is now doing the same thing at cosmological scale. The JWST survey, the CEERS survey, the Cosmos Web survey. All three are pulling out anomalous, compact infrared sources in numbers that were not predicted by any pre-launch model. The little red dots alone, first described in detail by Jorrit Matthey and colleagues in 2024, number in the hundreds. Some estimates now put the total population of unexplained compact high redshift sources in the low thousands. Most of these will turn out to be exotic but explainable objects, overmassive early galaxies, unusual dust configurations, weird active galactic nuclei. Fine, let us be generous. Let us say that 99% of these are absorbed into some patchwork of standard model extensions. That still leaves the last 1%. Hundreds of compact infrared sources with signatures that fit no known object. This is where the intuition of scale breaks. The human mind is wired to treat a single anomaly as noise and a large sample as signal. What Webb is producing is the moment when noise crosses into signal. It is the transition point that turned pulsars from a curiosity into a new class of star. It is the transition point that turned quasars from a puzzle into evidence of supermassive black holes. It is the transition point that turned the anomalous perihelion of Mercury from a footnote into the confirmation of general relativity. Populations force interpretations, and the population is here. If even a small fraction of these objects are what a fringe of physicists is starting to say they might be, the implication does not stay in astronomy. It reaches all the way down to what it means to be a human being living on a planet. Here is a number to hold in your head: 4.24 light years. That is the distance from Earth to Proxima Centauri, the nearest star to our own sun. At the speed of Voyager 1, the fastest object humans have ever launched into deep space, that trip takes about 75,000 years. Every romantic idea we have about becoming a spacefaring species, every plan for a Mars colony, every fantasy about seeding other worlds, sits on the far side of that number. Distance is the wall that defines our species. Distance is the reason we are alone. Distance is why every episode of every science fiction show has to invent some kind of faster than light travel to make the story work, because without it, the story does not work. A wormhole does not shorten distance. A wormhole cancels it. That is not a small distinction. That is the difference between climbing a mountain and stepping through a door. If even one confirmed traversable wormhole exists anywhere in the observable universe, the entire physical premise of human isolation collapses. The sky above your head stops being a ceiling. It becomes an opening. And once you sit with that image for a moment, the darker version of it arrives on its own. If wormholes exist, they have always existed. General relativity does not turn on and off. If the geometry is possible now, it was possible 1 billion years ago and 10 billion years ago. Which means, at some point in the history of the universe, if any civilization anywhere ever developed the ability to use them, we have been reachable, this entire time. The isolation you feel when you look up at the night sky is either a fundamental physical fact, or it is an illusion produced by our own inability to see the doors that are already there. This is what physicists mean when they talk about the Fermi paradox in its hardest form. Where is everybody? The paradox becomes far more uncomfortable if the distances that were supposed to explain the silence turn out to be optional. Webb is not just looking at old light. Webb is looking at a possible answer to a question we have been asking since we first understood how big the universe really is. But before we get carried away, we need to look at what the institutions doing the discovering are actually willing to say out loud. Because there is a reason none of this has been announced. Peer review in the field of cosmology takes between 12 and 36 months for a claim of moderate significance. For a claim that would rewrite the standard model, it takes longer, and it takes an army of confirming observations. Nobody wants to be the first author on the paper that turned out to be wrong. Careers end that way. Grants disappear that way. The entire economic structure of academic astronomy is built around extending, refining, and elaborating the current framework. Look at the National Science Foundation grant database. Look at the European Research Council awards. Proposals framed as tests of lambda CDM, the standard cosmological model, get funded. Proposals framed as tests of exotic topology, alternative geometries, or non-standard gravity do not or do so at a fraction of the rate. This is not conspiracy, this is incentive. James Webb itself is oversubscribed by a factor of 9 to 1. For every hour of telescope time available, there are 9 hours worth of proposals. The proposals that win are the ones that align with what the community already expects to find. The ones that would test the most disruptive hypotheses get almost none of it. Now look at history. Dark energy was proposed based on data from 1998. It took until roughly 2011, 13 years, for the acceleration of the universe to be widely accepted, and even then the Nobel Prize was necessary to close the deal. Cosmic inflation, first proposed by Alan Guth in 1980, took nearly a decade to become mainstream. Gravitational waves, predicted by Einstein in 1916, were not directly detected until 2015. 99 years. Even after the LIGO detection, it took another year before the community stopped hedging. The lag between when the data exists and when the community admits what the data means is not a scientific problem. It is a sociological one. The system is designed to be slow, cautious, and self-protective, precisely at the moments when speed and directness would matter most. If the Webb data really does contain the observational signature of exotic geometry, the timeline for that being publicly acknowledged is not months, it is years. And you, watching this, are being told a version of the story that has already been softened, sanitized, and filtered through the same institutional caution that kept dark energy in scientific limbo for over a decade. Which is why the language coming out of NASA right now deserves a much closer read than most people are giving it. Go back and read the NASA press releases about the strangest Webb findings. Read them slowly. You will notice something. The words that appear over and over again are surprising, unexpected, challenges our understanding, and consistent with early galaxy formation. Every one of those phrases is doing the same job. It signals excitement to the general public, while committing to nothing that would force the standard model to bend. It describes anomaly without naming it. This is not accidental. This is trained. Every major scientific institution has a communications office whose job is to translate research into language that does not embarrass the institution if it turns out to be wrong, and does not spook the funding agencies if it turns out to be right. Watch what happens with the little red dots. When they were first announced, the initial press coverage described them as, quote, a new type of galaxy. That is a phrase that means nothing. A new type of galaxy is still a galaxy. It fits inside the model. Within about 6 weeks of the initial reporting, follow-up statements began framing them as, quote, evidence for early black hole growth, which is a specific extension of the current framework that does not require any new physics. That is the pattern. A finding lands. For a moment, the language is loose enough that anything could be true. Then, within weeks, the language tightens around an interpretation that the standard model can absorb without breaking. Compare this to how gravitational waves were announced in 2016. LIGO waited until they had a 5 sigma detection. The press conference used the phrase, "We have detected gravitational waves." Direct, declarative, no hedging. Compare it to how cold fusion was announced in 1989, with a press conference before the peer review that turned into one of the most famous scientific embarrassments of the 20th century. The caution scales with the risk. And when you see NASA describing objects using 6 adjectives for every noun, you are watching risk management in real time. You are not being lied to. You are being paced. The rate at which you learn what the data actually shows is being controlled to protect the institution from having to say anything it cannot walk back. And the pacing exists because the alternative interpretation, whatever it turns out to be, is bigger than any single discovery. It is bigger than one object. It is bigger than wormholes. It is bigger than Webb itself. Here is the harder truth, and it is the one that will still be true. Even if every single one of the anomalous objects Webb has found turns out to be an exotic but explainable galaxy. The Hubble tension, the disagreement between the 2 main methods of measuring the expansion of the universe, is real, and it is growing, not shrinking. The impossibly early massive galaxies are real. The little red dots are real. The anomalous ionization is real. The missing satellite galaxies around the Milky Way, the sigma 8 tension between predicted and observed clumpiness of matter, the cosmic dipole anomalies. These are 6 independent lines of evidence in 6 different subfields, all suggesting that lambda CDM, the standard model of cosmology, is failing at multiple points at once. Any one of them alone could be a systematic error. All 6 of them together cannot. This is what a paradigm crisis looks like from the inside. It does not look like a single dramatic experiment. It looks like a slow accumulation of small failures, each one absorbed by patches to the theory, until the patches themselves start to look like the theory. In 1900, Lord Kelvin gave a famous lecture in which he said there were only 2 small clouds on the horizon of physics. One was the failure of the ether experiments. The other was the ultraviolet catastrophe, the failure of classical physics to predict the radiation from a hot body. Both looked like minor puzzles. Both, within 30 years, had become special relativity and quantum mechanics. The framework of the 19th century was destroyed not by one great discovery, but by two anomalies that would not go away. What Webb is showing us is not one anomaly, it is six arriving at once. Whether the specific interpretation involves wormholes, or modified gravity, or a fundamentally different topology of space-time, or something we have not yet named, the shape of the situation is the same. Every physics textbook printed before 2025 may be describing a universe that does not actually exist. Not in the sense that the equations are wrong, in the sense that the equations describe a special case of a larger reality we have not yet mapped. And that brings us all the way back to that first image, the one nobody wants to be the first to explain. Let us be very careful about what this video is saying and what it is not saying. It is not saying that NASA is lying. NASA is doing exactly what large scientific institutions do, which is to communicate cautiously about findings whose full implications are not yet clear. It is not saying that wormholes have been confirmed. They have not. It is not saying that physicists are incompetent or that the standard model is worthless. Lambda CDM is one of the most successful scientific frameworks in human history, and it has explained an enormous fraction of what we observe. What this video is saying is much narrower and much harder to dismiss. The physical reality that Webb is showing us is harsher than the comfortable public framing. The data is running ahead of the framework. The framework is running ahead of the press release. And the press release is what you are being told the universe is. Somewhere in that gap between what the data shows, what the theorists suspect, and what the public is allowed to hear, there is a story about a smudge of infrared light with no host galaxy, no matching spectrum, and no clean explanation. Maybe it is a very early, very unusual galaxy. Maybe it is a direct collapse black hole in a phase we have never observed. Maybe it is a primordial black hole from the first fraction of a second after the Big Bang. Maybe it is, as a small number of serious physicists are now willing to publish, the mouth of a wormhole. Whatever it is, Webb has done exactly what it was built to do. It has shown us that we were not ready for what we would find. Every paradigm shift in the history of science felt like this in the years before it broke. The scientists were cautious. The institutions were slow. The public was told a comfortable story. And underneath all of it, the data kept accumulating in defiance of what everyone thought they knew. That is not a failure. That is how science actually advances. The discomfort you feel right now, watching a video that ends without a clean answer, is the same discomfort that physicists felt in the years before quantum mechanics, in the years before relativity, in the years before the acceptance of dark energy. It is the discomfort of a framework that no longer fits. The sky you looked up at yesterday is not the sky you are looking at now. Somewhere in the archive of the James Webb Space Telescope, there is an image of a faint infrared source with no easy explanation. It might be the first confirmed wormhole in the history of human observation. It might be the first sign that our physics has hit its own edge and needs to be rebuilt. Both of those endings are, in the end, the same story. And the only honest thing left to do, when you look at that image now, is to admit that we do not know what we are looking at. And that used to be enough to change everything. Because science does not begin when someone finds the answer. Science begins the moment someone is forced to admit that the question is bigger than they thought. Webb has put us there. Whatever that faint infrared source turns out to be, it has already done its job. It has broken the silence of a universe we thought we understood. It has reopened questions we thought were closed. It has forced a generation of physicists to look at their own textbooks with the quiet suspicion that some of the chapters may need to be rewritten. And it has done something even harder. It has forced the rest of us, the people who do not build telescopes and do not write papers, to sit with a version of reality that is stranger, older, and more open than we were ever told. The night sky for the entire history of our species has been the ultimate symbol of what is out of reach. Every myth, every religion, every poem about the stars starts from that assumption, that the sky is far away, that the stars are unreachable, that the space between them is a fact of nature. Webb may be quietly telling us that none of that is true, and the strangest part of the whole story is not the physics. The strangest part is that this may all have been sitting in the data the entire time, waiting for an instrument sensitive enough to see it, and a public willing to hear what it means. Whether that public is ready is a different question. But the data does not care whether we are ready, it is already here, and it is not going away.